You say it may be.
Yes, I'm not sure.
You're not sure. Well, let's not pursue that. But one point I do want to take up with you, leaving even religion aside, is that now that science is seen in this entirely different way that you've been describing by virtually all scientists, doesn't it mean that the difference between science and non-science isn't what it was always thought of as being? In other words, since science is so subjective, indefinite, changing, and so on, it's no longer a clearly cut and different kind of human activity or kind of human knowledge from other sorts of human knowledge and other sorts of human activity.
I think that's both true and culturally very important. I think the harm that the old picture of science does is that if there is this realm of absolute fact that scientists are gradually accumulating, then everything else appears somehow as non-knowledge, something to which even words like true and false can't properly apply. I think that the so-called fact-value dichotomy is a very good example of this. It's hard to have a discussion on politics, for example, without someone very quickly saying, at least in my country, is that a fact or a value judgment? As though it can't be a fact that Hitler was a bad man, for example, or a fact that Farrah Fawcett Majors is a beautiful woman.
And do you think that it is a fact that Hitler was a bad man?
Oh, yes, I do.
I do too, yes. But then if this is so, if we are abandoning so many of these comfortable, clear-cut distinctions of the past, what's the point of continuing to use the category or the notion or the term science anyway? I mean, does it any longer clearly demarcate something differentiable from everything else?
I don't think it does. I think that, if you're going to distinguish science from non-science, that makes a lot of sense if you still have this old view that there's this inductive method. What makes something science is that it uses it pretty consciously and pretty deliberately, and that what makes something non-science is either it uses it entirely unconsciously, as in learning how to cook, you're not consciously thinking about inductive logic, or perhaps doesn't use it at all, as metaphysics was alleged not to use it at all, I think unfairly. But both say that there's a sharp line between, say, practical knowledge and science, and to say that the method which is supposed to draw this line is rather fuzzy, something that we can't state exactly, and attempts to state it, by the way, have been very much a failure still. Inductive logic cannot be, say, programmed on a computer the way deductive logic can be programmed on a computer. And I think the development of deductive logic in the last 100 years and the development of the computer have really brought home very dramatically just what a different state we are in with respect to proof in the mathematical sciences, which we can state rigorous canons for, and proof in what used to be called the inductive sciences, where we can state general maxims, but you really have to use intuition, general know-how, and so on in applying them.
One of the two categories that you described, the old-fashioned way of looking at science in terms of, was that there was a particular scientific method.
Yes.
That you observed the facts, and on the basis of these observed instances, you generalized to form scientific theories which you then verified by experiment and so on. That was the old view, wasn't it? Now that that has been abandoned, is there any longer any single method which is thought of as being scientific method?
I don't think there should be. People talk of scientific method as a sort of fiction, but I think that even in physics, where you do get experiments and tests which pretty much fit the textbooks, there's a great deal that does and then a great deal that shouldn't. And I think, in fact, in the culture, I don't really believe there's an agreement on what's a science and what isn't. Any university will tell you in its catalog that there are things called social sciences, not sociology as a science, or that economics is a science. I bet if you ask anyone in the physics department whether sociology is a science, he'll say no.
And why will he say no? That's interesting.
I think the real reason is not that the sociologists don't use the inductive method. They probably use it more conscientiously, poor things, than the physicists do. I think it's because they're not as successful.
So in other words, science has become almost a name for successful pursuit of knowledge.
That's right.
Yeah, yeah. Well, now, I think you've given a very, very good description of the way in which this age-old view of what science was has broken down in our century and been replaced by something much more fluid and perhaps much more difficult to get hold of, but you have, I think, described it very clearly. Can we now come, against this background, to what philosophers of science are actually doing? You are a philosopher of science. What do you and your colleagues do?
Well, part of what we do, which I won't try to describe on this broadcast, is fairly technical investigation of specific scientific theories. We look at quantum mechanics very closely. We look at both to learn what lessons we can from it for philosophy and to see what contributions we can make as philosophers to clarifying its foundations. We look at relativity theory very closely. We look at Darwinian evolution very closely and so on. This is the part of philosophy of science that provides the data for the rest. But much philosophy of science shades over into general philosophy, and I think the best way to describe it is in terms of what we've been talking about. That is, each of the issues we've been talking about divides philosophers of science. There are philosophers of science who have a correspondence view of truth and try to show this can be made precise, that the objections can be overcome, you can still view science somehow in the old way, and there are others who try to sketch what another view of truth would come to. There are philosophers who still think there is an inductive method that can be rigorously stated and who work on inductive logic. And by the way, I think it's important that there should be, because we won't make progress to trying to state the inductive method if there aren't, and that there are others who view the development of science more culturally, more historically, and there are people like myself who have a sort of in-between position. I think there's something to the notion of a scientific method, there are clear examples, but that it's more or less a continuum, that you mustn't think of it as a kind of mechanical rule, an algorithm that you can apply to get scientific knowledge. So that I'd say each of these issues, the nature of truth, the nature of the scientific method, whether there's any necessary truth in science, anything conceptual contribution which is permanent and can't be subject to revision is a big question.
And who are you, plural, doing all this work for? I ask that. I don't ask that in an irreverent way, but what I have in mind is this. I've myself taken part in attempts to bring scientists and philosophers together for discussions of precisely the issues that you've raised. And these attempts have usually failed, and failed for the same reason, namely that the scientists lose interest. They go back to their laboratories and get on with doing more science, and the great bulk of working scientists, it seems to me, don't in fact take very much of an interest in the issues that you've been talking about. I think it's conspicuous that the greatest of all scientists are exceptions. I mean, the really blockbusting, the path-breaking scientists who've actually made the revolution in this century that you've been talking about, people like Einstein, Max Planck, Niels Bohr, Max Born, Schrödinger, de Broglie, these people were enormously interested in the conceptual questions that you raised. But these were the pioneering geniuses, and the great mass of thousands of scientists who follow on behind them and put their work to its practical application. They don't seem to care. So who is listening to you? Who is reading the stuff that you publish?
Well, I'd say, first of all, I think we are basically writing for the philosophically interested layman, for the reader of philosophy. I don't view philosophy of science as giving direct advice to scientists, just as I think moral philosophers are ill-advised to think that they're giving at least immediately current contemporary advice on how to live your life or what bills to pass in Parliament. On the other hand, I do think that scientists tend to know the philosophy of science of 50 years ago. And perhaps this is the bad thing, that is, perhaps this time lag, this culture lag, has some value in weeding out what they shouldn't pay attention to. I mean, it's annoying to a philosopher to encounter a scientist who's both sure that he needn't listen to any philosophy of science, and then who produces verbatim ideas which you can recognize as coming from what was popular in 1928.
And is there a direct parallel here between what you're saying about scientists and Keynes, the economist Keynes's famous remark that nearly all businessmen who thought that they were indifferent to airy-fairy economic theory were in fact the slaves of the economic theorists of yesterday, of a previous generation?
That's exactly true.
I suppose another parallel one could make would be to say that the account that ordinary language users give of language and their use of language would be extremely unsophisticated, simply because they take it for granted and have never thought about it. That too would probably apply to the account that most scientists would give of what they were doing when they were doing their science.
That's right. That is, it's a mistake to think that merely because one practices an activity, one can give a theory of it.
One criticism that's often been made about philosophers of science is that although they talk of science in this general way, what they're nearly always referring to, in fact, is one science, namely physics. Now, it's true, isn't it, that the science in which the most exciting developments have probably taken place in the last 20 years, anyway, has been not physics, but biology. Our philosophers of science genuinely open to the criticism of being too physics-based in their view of science and having ignored biology too much.
I think I would defend us against that on the grounds that I don't, although the theories in biology are of great scientific importance, Darwin's theory of evolution, Crick-Watson on DNA and so on, they don't by and large pose big methodological problems of a kind that don't arise in physical science.